Hi, in this tutorial, we're going to go over a few new things. So first we're going to show different activation functions in Torch and just what they look like. We're going to look at, in particular, the Mish activation function. I'm also just going to give a quick example of showing some functional programming, which can be a little bit different in some other languages. So we're going to start from this notebook here, which is in the tutorial 3 folder. And we want to show different activation functions in Torch. So I'm going to first define a list with different activation functions. So I'm going to call it functions equals and some x values that we're going to evaluate our function at. So I'm going to say x equals. Just going to find out how many functions I have. So this is where the functional programming is coming in. I'm actually defining a list of functions. Also, size b. So if we got a comma here, there we go. So now we actually need to do our plotting. So do it again. And there we go. So you can see these 4 different functions: so Lu, JLu, HardString, and SeiLu. However, we want to also consider Mish. So I'm going to define a new function, just call it add it here to my list, and we can redo the whole thing. There we go. You can see that it's actually quite similar to the JLu and SeiLu as well. And if you read the paper on the Mish, it claims that it performs better on a wide variety of benchmarks, which is really interesting. In particular, the reason why we're even looking at these activations is in the next tutorial, I want to kind of investigate some calculus ideas of finding the derivative of y with respect to x instead of the loss function, the derivative of the loss function with respect to x. So we're going to look at how we can do that, but if we take the loss, if our multi-layer perceptron has a ReLU in it, this can create some problems because the second derivative in particular is going to always be 0 for any input because it's just a constant. It's a constant slope. So if we take the second derivative, the first derivative would just be the slope on this part of the ReLU. However, if I take the derivative of a constant, I'm just going to get 0. And that's going to create some major problems. So that's why we want to look at some other activation functions. And that's what we've done here. So this gives you a good idea of what the different functions look like, and also some really simple techniques on functional programming, how we can actually pass a function, or we can use handles to functions in order to accomplish what we want. So thanks for watching.